We are ready for section 7.5. It's titled Properties of Logarithms. So ultimately, there are some log equations that we want to be able to solve that we can't yet until we learn a couple of properties. So really, there's three properties. First one, let's go ahead and write it this way. If you have log base b of m, and you're adding to it log base b of n, we can actually take and summarize that, or we use the word condense that down into one single logarithm. Notice that they both use log base b. Log base b is going to be the type of log we have, but you'll take the m and the n that were in both logs. Before we were adding the logs together, but when we bring them together into one single log, it's multiplication. You'll say m times n. So log base b of m times n. Similarly, let's look at subtraction. So here we'll look at log base b of m minus log base b of n. In the last one, the two things were added together, and we then multiplied the m and the n. This time, since we're subtracting the logs, we are going to divide the m and the n. So we'll make a fraction. Log base b of m over n. So you want to remember that when two logs are added together, you're thinking about multiplication. When they're subtracted, you're thinking about division. And then the third property, we start with just a single log, but we give it a coefficient. So if we took n times log base b of m, so that n kind of acts like a coefficient there, we can write that as a single log, but without a coefficient. What we'll do is that n becomes an exponent on the m. So it'll be m to the power of n. All right, so those are our three properties. What I want to do is take those properties and apply them. This is the supplemental piece that you don't see in your book, but we're going to supplement it both in our notes and then also through a worksheet on the assignment. What we're just going to kind of play with those properties for a little bit. So the first thing we're going to do is we're going to do some condensing. When I say condense, that means we're going to take multiple logs, combine them together into just one single log. So let's do log base 3 of 2 minus, sorry, plus, I'm going to do plus there, plus 4 log base 3 also of, let's go with 3 there, sorry, log base 3 of 3 minus 2 log base 3 of 4. Let's do that. So you'll see that we have multiple logs here. They're all log base 3s. And I just want to, instead of having 3 separate logs, write them as one single log. Now, I'm going to maybe skip a step that some people would do. They would take those coefficients, rewrite it, and just move those into exponents. But I think we can handle just jumping all the way down to one single logarithm. We know it's going to be a log base 3. And then I would ask you this question. Before I go any further, are we going to have a fraction? We are, and the reason we know we're going to have a fraction is because of the subtraction. Now, here's where a lot of people make mistakes, and I get a little grumpy about this. If you're going to make a fraction, please don't make a fraction like that. because what I did there, what I don't like that just happened there, was the fraction bar passes underneath the log base 3. When we have a fraction, that log base 3 is not, it's neither in the numerator or denominator, it's outside of the fraction. So we'll have a log base 3, and then we're going to have a fraction, but the log base 3 is outside of that. So let's think about the numerator. What goes in the numerator? Well, notice the first log was of 2. Is that 2 going to go in the numerator? The answer to that is yes, and it's because that log was positive. So the 2 goes there in the numerator. The only way we get a denominator is if we're subtracting. The next thing that I was taking a log of was the 3, but notice the coefficient of 4. According to that last property, we know that coefficient turns into an exponent on the 3. So we can think of that as 3 to the 4th. Does that 3 to the 4th go in the numerator or denominator? Numerator, and the operation that connects the 2 and the 3 to the 4th is multiplication. It's the first property there. Two logs were added together. So we multiply 2 and 3 to the 4th. Then we have a subtraction. So now I know I move to the denominator. So we have the 4, but notice that it also had a coefficient, which is going to become an exponent on the 4. So that's a 4 squared. And because it was subtraction, we know 4 squared goes to the denominator. I do want to simplify this problem. So there in the numerator, I have 2 times 3 to the 4th. Well, 3 to the 4th is 81. So I can take 81 times 2, 162. So 2 times 3 to the 4th is 162. In the denominator, 4 squared is 16. That fraction can be simplified because I can divide them both by 2. That's the only thing I can divide them by. So 81 fourths, log base 3 of 81 fourths. It would be over 8, not 4, sorry. Thank you for that. (81 eighths). That's what I would expect for an answer. Now, it's possible, and this is I would call this a little bit more advanced, but is actually better, and it does simplify to something probably a little bit nicer. But take a look right here at that log that I have underlined. What's true? So it's a log base 3 of 3. I know it has a 4 in front of it, but do we know what log base 3 of 3 equals? What is log base 3 of 3? It's just a 1. If you would have realized that, if we would have realized that right away, we could have just changed that to 4 times 1, and it's not a log at all. What would we have done in that case? Well, you could have just left that 4 separately, and then we would have had a log base 3 of the rest of 2 over 16, which is 1/8. So is that necessarily any better? Does it look any nicer? Maybe, maybe not. I still don't necessarily know what log base 3 of 1/8 is, but it's something smaller inside the log. So that would have been okay. If you would have noticed that, awesome, more power to you. But no worries if not. I'm going to go ahead and erase that and leave the first answer we had. Okay. Let's do another condensed problem. Let's go log base 4 of A minus 3 log base 4 of B. plus 1/2 log base 4 of C minus 1/3 log base 4 of D. We'll just go ahead and do that. So I happen to have 4 logs. In this case, I can have any number of logs. I could keep going. But they're all log base 4s, so I know it's going to condense to a log base 4. Will we have a fraction? As long as you see any subtraction there, we will have a fraction. Go one piece at a time. The first log was of A. It was positive, so it goes in the numerator. No coefficient, so it's just a standalone A. The next one is a log of B. There was a coefficient, so it's going to be B to the third, and it's located in the denominator because it was a negative log. The third log has the C with the 1/2. So C to the 1/2. We don't necessarily typically write C to the 1/2. What's an alternative way to write C to the 1/2? An exponent of 1/2 is the same thing as a square root. So I would write that as the square root of C. It does go in the numerator because it's positive. Square root of C up there. And then the last one, the D, has a 1/3, which is also a fraction. So I can write this in a root form. Notice this one's in the denominator. That's a 1/3, so it's a third root, not a square root, but a third root of C. Or sorry, that was of D. Zoom in a little bit so you can see that, especially the third root there, piece better. If it's a negative in front of the log, that means that, yeah, we look at the, whoops, zoomed out a little farther. Means it was from the second property. If 2 logs are subtracted, we know the one after the subtraction goes to the denominator. So anytime you have a negative log, that log is going to go to the denominator. So I had 2 negative logs that time. Those, the B and the D, those are the ones that went to the denominator. Someone may say, hey, we have a square root or a third root, a radical in the denominator, and that's not allowed. We dealt a long time with that last unit. And I would say, you're right. And if you want to fix it, go right ahead. And that would be a wonderful thing to do. But the main idea we're trying to get across is how to expand and condense. And I don't want to take the time to rationalize our denominator in this case. You could leave it like that on a test, yep. And if you rationalized it, I would maybe draw a smiley face or something. Okay, so that's condensing. We can also go the other direction. We call it expanding. This is working backwards. I gotta erase some of this stuff down here. Thought I had erased that before, sorry. I'm sure I'll have more to get to in a little bit, but okay. Oops. Let's go with the log base 5 of 2 a to the third 4th root of b. So right now I have it as a single logarithm, and if we're expanding, we don't want it as a single logarithm. I want to separate into multiple logs, so each one's a simple log, if you will. There's advantages, times where we want one way or times where I want the other way. So we want to be able to go both directions. So my first question is, how many logs will we have in this problem? There will be 3. We'll have to have a log of the 2. We'll have to have a log of the A, and we'll have to have a log of the B. Right? We have basically 3 bases there, so we're going to have 3 logs. Each of them will be a log base 5. So I'm going to write log base 5 of 2 and log base 5 of A and log base 5 of B, but I'm just going to leave some space in case we have coefficients and also add in positive or negative signs. So let's start with that. Just leave space, but log base 5 of 2. Then I'll have a log base 5 of A. Then I'll have a log base 5 of B. So now I will deal with coefficients. Will any of those logs have a coefficient? The A one had an exponent of 3, so in front of that A log, I would write a coefficient of 3. What about the B? It was a root, so we know it's going to be in fraction form. It'll be 1/4. And then the last thing I have to do is state whether they're added or subtracted. Notice there was no fraction here. Everything was multiplied together, so it's just addition. They're all positive logs. So we get log base 5 of 2 plus 3 log base 5 of A plus 1/4 log base 5 of B. That would be our answer. And we'll do one more expanding problem. After that, we'll jump back into our textbook material. It's the stuff they mostly cover, and we'll actually use this to solve some equations. So number 4. Log base 3 of, in the parentheses, A, B squared, C, and that whole thing to the power of 3. And then in the denominator, I'll go with 2 times the square root of D. So, yeah, we're if you look at, different teachers' ways of doing this problem, they may do it in multiple steps. Because I'm kind of lazy, don't really want to drag this out into a bunch of different steps. Instead, I'm able, and I think you're able, to jump all the way to the answer kind of in one big step. So that's what I'm going to promote. But we have to be careful in doing that because there's several things happening all at once we have to keep track of. So my first question is, how many logs will there be? There will be 5 logs. I have the A, the B, the C, the 2, and the D, right? Not worrying about exponents yet, not worrying about roots, just bases, A, B, C, 2, and D. So I'm going to do a log base 3 of each of those. Once again, leave some space between. I'll have a log base 3 of A, log base 3 of B, a log base 3 of C, oops, a log base 3 of 2, and a log base 3 of D. Could I put those in different order? Absolutely. It doesn't really matter what order I put them in. I just went across the numerator and then down to the denominator. So let's go one at a time. The A, is the A one going to have a coefficient? I'm going to point out to us that 3 right there. That 3, that exponent of 3 is outside of the parentheses. So doesn't it actually affect the A, the B, and the C? So that's really A to the 3rd. So I will have a coefficient of 3 on that log. Look at the B. Notice the B already had an exponent of 2, and then I brought the 3 to it. What is that exponent now? What does it actually become? It becomes a 6. You would have to multiply those together. So it's B to the 6th. So you have a coefficient of 6 in front of that log. On the C, we'll get a 3. 2, does it have a coefficient? No, it was just a 2. What about the D? It'll be 1/2 because it was the square root. And then the only thing left to do is positive or negatives. The A, the B, the C all came from the numerator, so those are all positive logs. So the first three are all positive. The 2 was in the denominator, so it's going to be a negative, so minus log base 3 of 2. The D was also in the denominator, so I put a negative in front of that log as well. And there's my answer all expanded out. Okay, so now we're going to take a look at what our book spends most of the time on. Most of these examples, you're not going to find problems like this in the textbook. But we're going to now use that to solve some problems. So this is really the main idea of the section. So solve so we have an equation we're trying to solve. We have logs. How is this different than last week? Well, the problem is, in this particular case, is the left side of the equation. I cannot just go and exponentiate right there because I don't have on the left side just a single logarithm. The right side is, but the left side is not just a single logarithm. But can't, using the properties we just practiced, can't we condense that down into a single logarithm? That's what we'll need to do first. So it will be a log base 2. Is it going to be a fraction? Yes, because of that minus. The x, notice it's going to be x to the 4th. We'll have to go in the numerator. And the 5 goes in the denominator. So we can write it this way. Would it have been possible to add the log base 2 over to the other side, the log base 2 of 5 over to the other side? Yeah, you could have, and then you would have had 5 times 125. That would also work. That's what's going to happen in a little bit anyway. But we went ahead and condensed down so each side has a single log. Now we can go back to what we did last week. How do we get rid of a log? Exponentiate. So I chose to use a base of 2. I went 2 to the power of the left side is equal to 2 to the power of the right side. 2 to the log base 2 cancels out on both sides. So we're now left with x to the 4th over 5 is equal to 125. And I want to solve that equation. So propose that we would multiply both sides by 5. At that point, I have x to the 4th is equal to 625. How do I get rid of a 4th root? I have to do how to get rid of the 4th power? We do the 4th root. Because that's an even root, what is it that I have to concern myself with? I have to remember, just like when we do a square root, if it's an even root, you have to do plus minus. So we get x equals a positive, negative, and what's the fourth root of 625? 5. So I get two answers, a positive 5 and a negative 5. And then remember back to last week when we had log equations, did all of our answers inherently work or necessarily work? No, you have to check them because logs do have domain restrictions. You can't take logs of just anything. So we have to test them and make sure they actually work. So, and you test them back in the original equation before we did anything. Let's check 5. 4 times log base 2 of 5 minus log base 2 of 5 equals log base 2 of 125. Does it appear to work at first glance? I would say yes, or at least possibly, because we didn't have an issue of taking a log of a negative number. That's usually where the problems arise. It's not log base 2 of a negative thing. So it's probably going to work. But how can we check this? Notice log base 2 of 5 is in both of them. It's kind of like having 4x minus x. 4x minus x would be 3x. Well, in the same way, 4 log base 2 of 5 minus the log base 2 of 5 is 3 log base 2 of 5. So that would be an easy way to start that simplification problem. And then we have this 3 in front. Doesn't that become an exponent? Becoming log base 2 of 125 is equal to log base 2 of 125. And yes, that works. What about negative 5? Let's check that one also. Is this one going to work? Don't bother bringing the 4 up as an exponent or even combining the two things together. We see right away a huge problem. We have a log of a negative number, and that is not possible. You can't do log base 2 of negative 5. So I have to cross that out. Therefore, negative 5 didn't work. 5 is the only answer that did. Okay, I want to do one more. Get rid of all that. Oh, froze up. There we go. Okay. I think we're ready for number 6. All right, hopefully. Let's go with log base 6 of x plus log base 6 of x plus 5 is equal to 2. On the left side, we have 2 logs. We need to make 1 log. Will this one be a fraction? No. So you take the x and the x plus 5 and you multiply them. So I would distribute while you're doing that. You get x squared plus 5x. Now we have a single log. Now it's like last week. So we need to exponentiate with the base of 6. X squared plus 5x is equal to, over on the right side, nothing canceled, so you actually have 6 to the second power, which is 36. Then as you consider this problem, looks like we need to set it equal to 0 and see if we can factor. So if we get a 9 and a negative 4, so if x plus 9 equals 0, then x would equal negative 9. And if x minus 4 equals 0, x would be a positive 4. So we have 2 answers. We need to check them. Negative 9 and 4. Plug them back into the original problem. Oops. Okay, so let's plug them in. Plug in -9 first. Is that a problem right there? Yes, it is. We get 2 negative logs, in fact. That's not going to work. So we can cross out -9. Check 4. Both of those logs are positive, so it seems promising. Go ahead and condense them together. It would become log base 6 of, we'd have to take the 4 and the 9, you multiply them together, you get 36. Is that a true statement? Is log base 6 of 36 equal 2? Yep, sure does. So we only had one answer, and it was 4.